Hello students, you are welcome to this lesson, lesson 6 of our year 1 semester 2 course manual. Today's lesson will focus on basic trigonometry. Our substrand is trigonometrical ratios and applications to real life. Our scope will cover misconceptions and barriers in the teaching of trigonometric ratios in specific, but generally mathematics. We'll also look at the basic trig ratios, popularly referred to as SOHCAHTOA, and then look at the applications of these ratios in real life. For a start, I need you to take a look at the triangle here. Take a good look at the sketch of that triangle or that shape. See how many triangles we can get out of that shape. I hope you are trying your hands on it. How many triangles can we get from the shape? I can hear a whisper, 5. 9. I can hear another one, 9. You have done very well, but please take a good look and try again, because there are as many as you cannot imagine. So keep trying, and then we'll see the one who has the highest number of triangles in that diagram. Right. We will hear from you in the comment sections about how many triangles you have been able to identify from that shape. Now, our first concern is about the conceptions in teaching mathematics in general, and then specifically trigonometrical ratios. Our very first concern is the fact that students usually say mathematics is for men, and so when women are found in mathematics classroom, they are usually adamant to whatever goes on in the mathematics class. They either give up on lessons or are not ready to contribute their quota in the learning sessions. I think this is a big misconception that it needs to be well dealt with. If we come to the specific situation of trigonometry for that matter, the misconception is that it doesn't have a real life application. So students will usually ask, where would this one apply? Where would we make use of this topic? But the truth is that trigonometry has a lot to do with our real life situations, from measurements to angles and their measurements and what have you. A particular reference is to the situation where someone needs to find the height of a tree, and the person has no instrument, as it were, to be able to reach the top of the tree. Trigonometry can help us find the height of the tree if we know the distance the person is standing away from the tree, and then we are able to tell that distance, and we know the angle the top of the tree makes with the eye level of the person who wants to find that measurement. And so these and other cases in life are situations in which we can apply trigonometry. Now, if we have a right angle triangle, basically trigonometry will be helping us to be able to name or identify sides of the right angle triangle with reference to an angle. So if this is a right angle triangle, we have an angle of reference, let's call it theta. And it is a right angle triangle because it has a 90-degree angle in there. Theta happens to be an acute angle. And so with this, we can have a lot of things to do about that triangle. For example, if we label our sides A, B, and C, we can name all the sides. From our previous lesson, we realized that there's only one side we can name. That was with reference to Pythagoras' theorem. And that is the longest side of a right angle triangle, or the side that is facing the 90-degree angle. And that side is known as the hypotenuse. Now, with reference to the angle theta, we can name all the other sides of the triangle. Now, theta is an interior angle in the triangle, and so the line or the side A facing that angle theta is referred to as the opposite side. And so the last and the final side of the triangle will be called the adjacent side. So here we are with our right angle triangle. We have 3 sides, and all the sides have been labeled or named accordingly. And remember, the name of the other 2, apart from the hypotenuse side, is based on the angle of reference. And so if we have another triangle, right angle triangle for that matter, and our angle of reference is here, alpha, can we name the sides of that triangle? I am sure you can. And so you have your hypotenuse being the side facing the right angle. The side that is facing the angle alpha will be the opposite side. And the last side will be our adjacent side. Now we'll be interested in finding the basic ratios for these triangles with reference to angle theta and alpha. Now the basic trig ratios are sine, cosine, and tangent. They are ratios because they make use of two sides of a right angle triangle at a time. So the ratio for sine, if we are making reference to our angle theta, the ratio for sine is the opposite side divided by the hypotenuse side. And so, for want of easy remembrance, we would usually say sine has the ratio opposite divided by hypotenuse. And that is how come we get the SO as the short form for the ratio sine. If we come to cosine, usually we will write cos of the angle, so we'll call it cos theta. The short form for cosine is cos. And so that ratio would give us the adjacent side divided by the hypotenuse side. So with reference to our triangle right here, the adjacent side is labeled C and our hypotenuse is labeled B. And so that is how we can get the ratio for cos theta or cosine of theta. When we come to tangent also, we have tan to represent tangent. And so tan of theta will give us adjacent divided by the opposite. Adjacent divided by the opposite. So here, with reference to our first diagram, we have the adjacent side being the label C and the opposite side being labeled A. So, where does the SOHCAHTOA come in? It comes in when we try to simplify our ratio just by taking into consideration the first letters of our ratio. So sine theta will give us opposite divided by hypotenuse, and that gives us our SO. What then will be the short form or our key acronym for remembering cos theta, the ratio for cos theta? The letters we are considering are C, A, and H. And so we'll have K. And finally, for tangent, we have T, A, and O. So we have T, A, and O. A little correction here. Opposite divided by adjacent. So we have T, O, and A, giving us twa. And so ka twa basically refers to the basic ratios in our trigonometry concept. And so we can take time off and look at the relationship that exists among these trig ratios: sine, cosine, and tangent.